Hey there, and welcome. Today, we're going to pull back the curtain on one of the coolest, most spectacular shows in our entire solar system. It's not magic, although it totally looks like it, right? It's science. So let's dive right into this amazing cosmic event we call an eclipse. At its heart, an eclipse is way simpler than it sounds. It's basically just a giant game of cosmic hide and seek, with planets and moons getting in each other's way. So what it really boils down to is a giant shadow play in space. Seriously, one object moves in front of another, it blocks the light, and for a little while, something gets dark. That's really all there is to it. And from right here on Earth, we get a front row seat to two main types. To really get a handle on both of them, though, we first need to talk about shadows. Okay, so to really understand eclipses, you gotta understand shadows. And yeah, they have three parts with some kind of fancy names, but don't worry, they're super simple. We're talking about the Umbra, Penumbra, and Antumbra. All right, the Umbra. This one's easy. Just picture the really dark, sharp shadow right under a chair on a sunny day. If you were a tiny bug standing in that spot, you wouldn't see the sun at all. That super dark center part, that's the Umbra. Then you've got the Penumbra. That's the fuzzy, kind of lighter part of the shadow around the edges. If you're in the Penumbra, you can only see part of the light source, which is why it's not totally dark. Okay, and now for the special one, the Antumbra. This is a really cool type of shadow that only happens when the thing making the shadow looks smaller than the light source behind it. Now hang on to that thought, because it's the secret ingredient for a really awesome type of eclipse we're going to talk about in a minute. All right, now that we're shadow experts, it's time for the main event, Part 1, the Great Solar Eclipse. This is where our little moon somehow manages to block out the gigantic, mighty sun. So, for this to happen, the cosmic alignment has to be just right. You need the sun, then the moon, then the earth, all in a perfect line. And here's the crazy part. Even though the moon is tiny compared to the sun, it's just the right distance from us that its shadow can actually reach out and touch a little part of our planet. And remember our shadow lesson? Well, this is where it pays off. Where you are standing in the moon's shadow determines the kind of show you get. If you're lucky enough to be in that dark center, the Umbra, you get a mind-blowing total eclipse. If you're off to the side in the Penumbra, you'll see a partial eclipse. And what about that special Antumbra? Well, that's when you see an annular eclipse, where it leaves this incredible ring of fire in the sky. So cool. Okay, let's flip this whole thing around. What happens when our own planet, Earth, is the one making the shadow? So for a lunar eclipse, the lineup changes. It goes sun, Earth, and then the moon. Our whole planet gets in the way and casts its massive shadow on the moon. And what's really awesome about this is that, unlike a solar eclipse, a lunar eclipse is visible to, well, pretty much anyone on the night side of Earth when it happens. The whole hemisphere gets to watch. And just like solar eclipses, there are different types. The most spectacular one is a total lunar eclipse. That's when the moon goes right into the Earth's umbra, and it turns this spooky, beautiful reddish color. That's where it gets the name blood moon. Then there's a partial eclipse, where just a chunk of the moon gets shadowed. And a penumbral eclipse is super subtle. The moon just gets a little bit dimmer. Honestly, you might not even notice it if you weren't looking for it. So if you're trying to keep them straight, here's the simplest way to think about it. Just ask yourself, who's doing the blocking? In a solar eclipse, the moon blocks the sun. In a lunar eclipse, the Earth blocks the light from hitting the moon. That's the key difference, right there. Okay, so this probably has you wondering, the moon goes around the Earth every month, right? So why don't we get an eclipse every single month? Why isn't this a regular thing? Yeah, it seems like they should line up all the time. But the answer is in a tiny but super important detail about the moon's orbit. It's got a bit of a wobble to it. And that's the magic number, 5 degrees. The moon's path around the Earth is tilted by about 5 degrees compared to Earth's path around the sun. Now, 5 degrees might not sound like a lot, but over the vast distances of space, it's huge. It means that most months, the moon's shadow either flies way above us or way below us, and our shadow completely misses the moon. So for an eclipse to happen, that alignment has to be absolutely perfect, right at the point where those two tilted paths cross. It's like trying to thread a cosmic needle while everything is moving. It only happens a couple of times a year when things line up just right. All right, we've gone on a pretty cool cosmic journey. So let's do a quick recap and lock in the main takeaways. Okay, here's the cheat sheet. Super simple. Solar eclipse, the moon blocks the sun. Lunar eclipse, the Earth blocks the sunlight going to the moon. Umbra, that's the full, dark shadow for a total eclipse. Penumbra, that's the partial shadow. And Antumbra, that's our ring of fire shadow. Got it? Good. And I want to leave you with one last really cool thing to think about. Imagine you're an astronaut standing on the surface of the moon, and back on Earth, everyone's watching a lunar eclipse. What would you see? Well, you would see the Earth blocking the sun. You'd see a solar eclipse caused by our planet. You'd watch this giant dark Earth float in front of the sun, and all around its edge, you'd see a glowing red ring. And that ring is the light from every single sunrise and every single sunset happening on Earth, all at the same time. How amazing is that? Thanks for watching.